Next we look at the root test. So for the root test we need an infinite series with non-negative terms, and we let rho be equal to the limit as k goes to infinity of the kth root of a sub k. And if this value rho is greater than or equal to 0 and less than 1, we say the series converges. If it's greater than 1, the series will diverge. And if it's equal to 1, then our test is inconclusive. So let's determine whether or not this series converges. So I'm going to take the limit as k goes to infinity of the kth root of the terms, 4k squared minus 3 over 7k squared plus 6, all to the kth power. And here my kth power and kth root will cancel each other out. So I now have the limit of 4k squared minus 3 over 7k squared plus 6, which, since the degree of the top and the bottom is the same, we just need to look at the coefficients. 4 over 7, which is less than 1. So this series converges. Next, let's look at this series. So if I take the limit as k goes to infinity of the kth root of 2 to the k over k to the 10th power. Well, we can see that the top of this fraction will just become 2, and on the bottom we have the kth root of k to the 10th power. So let's actually further examine this denominator. I'm going to rewrite this denominator as k to the 10 over k, which I'll then rewrite again, k to the 1 over k to the 10th power. And we can double check that all of this is valid. When I have an exponent to an exponent, I would multiply. 10 times 1 over k is 10 over k. And so there is a limit of k going to infinity of k to the 1 over k, which is a very well-known limit, which is 1. So the limit of the denominator is 1 to the 10th power, which is 1. So if I go back to my original fraction, the limit would be 2 over 1, which is just 2, which tells us that this series diverges.